are going to be talking about exponents here. We're going to get ourselves kind of introduced by looking at some, as I call them, flashy lights going off in your head, numbers. So when you see these numbers, you should start thinking, that number looks familiar. Maybe it happens to be some number raised to a power. So this table is in your notes. Go ahead and make sure you complete it. You can even pause this video and kind of fill in some of the ones here. Some of these numbers we will be expected to know right away. The gray numbers, I think, are unreasonable to really expect you to know. I might even cross off some more of these numbers. I'm going to cross, well, let me not cross them off. Let me go ahead and kind of dark highlight here. I don't really expect you to know these here or those there. Those ones are a little bit large. Okay, so the rest of these numbers you should basically be recognizing right away, other than the gray shaded ones. So if we look for some patterns, looking at the numbers that are in the units place for the power of 2. So really, we start off with 2, and then we have 4, 8, 16. And then look, 2, 4, 8, 6. 2, 4, I said 16, 6 here. So 2, 4, 8, 6, 2, 4, 8, 6. That keeps repeating. So that is going to be a tip that you are working with powers of 2 if you see that kind of cycle going over and over again. What about for the powers of 3? We have 3, 9, 7, 1. 3, 9, 7, 1. And that repeats. 3, 9, 7, 1. Powers of 4 goes 4, 6, 4, 6, back and forth. And what about for the powers of 5? Goes 5, 5, just 5 every time. That makes that convenient. For the powers of 10 down here, you will of course have 0 in all their units placed, but you might notice that the power of 10 corresponds to the number of, well, when we have n to the third, 10 to the third, we have 1,000, 10 to the fourth, 10,000, 10 to the fifth, 100,000. So the power of 10 corresponds to the number of zeros. Great. So definitely spend some time, definitely with your numbers squared, numbers cubed, and like the powers of 2 especially. Those ones you should know pretty quickly. Okay. So let's get into an introduction of exponents. So 5 to the 6, as we know, means 5 times 5, 6 times. This works for fractions as well. If we have like something like 9 over 7 to the 4th, that means 9 over 7 times 9 over 7, 4 times. So this is called exponential notation in general for any number x and any positive integer n. X raised to the n power is x times x times x, n number of times. We call the number x to the n is called x raised to the nth power. N is the exponent, and x is the base. So we'll refer to x here as the base. So in our example at the top, 5 was the base, 6, of course, was the exponent. Okay, so what can we do with negative 5 times on and on and on? This dot means it keeps going. Negative 5 17 times. We could rewrite that as negative 5 raised to the 17th power. And if we have 3.7 times 3.7, and we see that that's equal to 3.7 times 3.7 to the 19th power, that means we must have multiplied 3.7 19 times. Okay, so we're going to rewrite some of these as powers of 2. So hopefully when you start seeing these numbers, you real quickly think, 8, that's 2 to the 3rd. 16 is 2 to the 4th. 32 is 2 to the 5th. 64 is 2 to the 6th. 128 is 2 to the 7th, and 256 is 2 to the 8th. So those should be popping quickly into your head. Okay, Tim wrote that 16, he wrote 16 as negative 2 to the 4th. Is he correct? Well, yes. Why is this? He's correct because negative 2 raised to the 4th power is the same as negative 2 times negative 2 times negative 2 times negative 2. And since if we were to multiply that out, we do in fact get 16. We can also kind of look at this and think that the exponent was even, which means we had an even number of negatives. So the exponent was even, so our answer will be positive. We could have represented it, Tim could have done 2 to the 4th to get us 16, but negative 2 with the parentheses to the 4th power is 16, so he is correct. Could negative 2 be used as the base to rewrite 32? Well, if I think about 32, if I was going to multiply 2 times 2 times 2 times 2, that's 16 times 2, that would be 32. So that's 5 2's. So if I tried to use negative 2 to the 5th power, because I need an odd power to get to kind of a number with an absolute value of 32, it's an odd number, so that means this would unfortunately give us negative 32, not positive 32, because we have an odd power there. For 64, we need 2 times 2 times 2 times 2 times 2 times 2, so that's 6 2's to give us 64. And negative 2 to the 6th power, because that's an even number of exponent there, that would give us 64. So it does work for 64, but not for 32. All right, let's look at Josie's work. Josie says that negative 15 times itself 6 times is equal to negative 15 to the 6th power. Is Josie correct? No, Josie is not correct, because negative 15 to the 6th power, this would really equal negative 15 times 15 times 15 times 15 times 15, and one more times 15. So 15 times itself 6 times, and then the negative tacked on. It's like the exponent is only latched on to the 15, not to the negative there. So we would multiply the negative by 15 to the 6th, and we would get a negative answer, whereas we know what we started with here, negative 15 times itself 6 times, that should be a positive number, but negative 15 to the 6th power, she wrote it, would give us a negative power. So that ultimately brings us to this important distinction, negative 2 to the 2nd power. That is negative, then 2 times 2, which is equal to, of course, negative 4. On the other hand, negative 2 in parentheses squared, that's negative 2 times negative 2. And negative 2 times negative 2 is positive 4. So we can clearly see we get a difference. When we have the parentheses around the negative, that means we're multiplying it every time that we use the exponent. When it's outside, it happens after the fact. It happens after we multiply all the numbers of 2 in this case. Okay, well, what happens if we had a fraction raised to all these powers? Well, 1/2 times 1/2 would be, well, 1/4. The numerator is just 1 times 1, the denominator is 2 times 2. Well, what happens about 1/2 to the 3rd? Well, again, numerator is 1 times 1 times 1, denominator is 2 times 2 times 2, so that's 1/8. So we're going to see a pattern here that it's going to kind of continue with our powers of 2 in the denominator, but 1 in the numerator. So 1 over 128, 1 over 256, 1 over 512, and 1 over 1024. And again, you should know those powers of 2 so quickly that you're not sitting there to use a calculator to figure out 2 to the 9th power. Okay, so let's look at some examples and actually do some simplifying. So if we see 3/5 to the 3rd power, you might need it at first, but this is really 3/5 times 3/5 times 3/5. So I recognize that I'm multiplying 3 times 3 times 3, which is 27, over 5 times 5 times 5, which is 125. So that is my simplified answer. Well, if we have 7 over 9 to the 2nd power, that means 7 over 9 times 7 over 9. So the numerator is 7 times 7 is 49, and the denominator is 9 times 9 is 81. Now notice, there was nothing I could simplify between the 7 and 9. Since there was nothing I could simplify between 7 and 9, there's nothing I can simplify between 49 and 81. So I don't have to worry about trying to simplify that fraction. Now if we look at number 10, we see negative 2 over 8. We can simplify that first. That's negative 1/4 to the 3rd power. So we have an odd exponent here. So our answer is going to be negative. A negative times a negative times a negative is a negative. Numerator is 1 times 1 times 1. Denominator is 4 times 4 times 4 is 64. So our answer is negative 1/64. All right, if we look at number 11, we've got, all right, 4 times 4 times 4 is 64 over 5 times 5 times 5 is 125. And we're multiplying that by our second fraction. 5 times 5 times 5 is 125, over 4 times 4 times 4 is 64. Interesting. 64 goes into 64 once, 64 goes into 64 once. 125 goes in once, and once, so, oops, and once. So we have just 1 as our answer. Nice. Okay. We could multiply these as they sit here, but we know that we can multiply things in different orders. So instead of multiplying 2 times x, then 2 times x, I could write this as 2 times 2 times 2 times 2. How many times have we got it? 6 2's here. Times 2 times 2. So 6 2's, and then x times x times x times x times x times x. So 6 x's. So that's 2 to the 6th power, which is 64. And x to the 6th power is x to the 6th power. So there we go. That's our simplified version for number 12. All right, let's look at 13. We're trying to solve 4x here. So 4 to the 3rd, well, that's 64, is equal to 2 to the x. Well, what power of 2 gives us 64? X is 6. Great. So notice we kind of tried to expand both sides as much as we could so we could find something that we could solve. 3 to the 4th power is 81. And that's equal to 9 to some power. Well, 9 to what power is 81? Oh, 2. So x is 2. Okay, over here, we have x to the 8th. Can't do anything with that side. 4 to the 4th. So 4 times 4 is 16, times 4 is 64, times 4 is 256. All right, something raised to the 8th power is 256. Well, again, hopefully the flashlight numbers are going off in your head, and you recognize, 2 to the 8th power is 256, so x must be 2. Spectacular. Okay, we want to be able to combine like terms when we're dealing with exponents, so in order for the terms to be considered the same, like terms must have the same variable, each raised to the same exponent or power. The order of the variables doesn't matter. So, let's look at a few examples and see, are they like terms or not? So we've got 3x squared and 3x to the 3rd. They happen to have the same coefficient of 3, but if we look at the variables, here's x to the 2nd power, and here's x to the 3rd power. Those are the same variable, but they're not raised to the same exponent. So, no, they're not the same. The x's are raised to different powers. Great. Here in number 17, we have 4x to the 5th and 9x to the 5th. Now we have a 4 coefficient and a 9 coefficient. Those are different. We're not concerned with that. We're looking, do they have the same variable, x? And is that x raised to the same power? Yes, 5 both times. So, yes, both have x raised to 5th power. Great. Lastly, we have x squared y cubed and x cubed y squared. Are these the same? No. Even though we see an exponent of 2 and an exponent of 3 and an exponent of 2 and an exponent of 3, they're on the wrong thing. So no, in the first term, x is squared, but it is cubed in second term. Okay, let's look now at the next set of problems here. It says, for part A, circle all the terms that are like terms with negative 4x to the 3rd, y to the 5th. Okay, so we're looking for x to the 3rd, y to the 5th, irrespective of the coefficient in front. So, this has an x to the 3rd, but not a y to the 5th. Not an x to the 3rd, but not a y to the 5th. All right, looking, here, we have an x to the 3rd, y to the 5th. So it says to circle that. Great. Keep looking, keep looking. In number 28, that's also x to the 3rd, y to the 5th. Looking, what's up with number 30? That's x times x times x, y times y, times y times y times y. Well, that really is 3x's and 5y, so that one actually is a like term. All right, what about this one here? Y to the 5th, x to the 3rd. Well, it still has x to the 3rd and y to the 5th, even though they're written in a different order. So that one works. Okay, so those four are like terms with x to the third y, with negative 4x to the third y to the fifth. You want to go ahead and do the same thing for putting a box around the ones that are similar to 5x to the third and underline the ones that are similar with x to the fourth, y to the seventh. All right, once you've done that, go through and put any x's through any terms that are not the same. But then in part E, what you have to go through is add the term that you were looking for, so negative 4x to the third, with your new term. So we had negative 4x to the third, we're adding it to 4x to the third, y to the fifth. So this would lead us to 0 for part E. For our next one, we had negative 4x to the third, y to the fifth. When we combine that, we have 8x to the third, y to the fifth. In number 30, that's 2x to the third, y to the fifth, and negative 4x to the third, y to the fifth is negative 2x to the third, y to the fifth. And then lastly, we have 3x to the third, y to the fifth. So that's going to give us negative x to the third, y to the fifth. Okay, great. Let's just do a little bit more practice here. I don't want to see any decimals for your answers in this section, so keep it to fractions. All right, so if we see negative 3/5 to the third, so right away I see a negative fraction, I see a odd exponent. So I know my answer is going to be negative. So I've got 3 to the third, which is 27, and 5 to the third is 125. No simplifying I could do, so that is our answer. All right, for number 35, I've got 3/4 to the fifth, and then multiplied by negative 1. So it's going to be a negative answer. 3 to the fifth is 243, and 4 to the fifth is 1,024. So that's our answer there, negative 243 1,024ths. For number 36, notice that 12 over negative 6 could easily be reduced to negative 2. Now, it's in parentheses, so make sure you put it to the third power. So that's negative 2 times negative 2 times negative 2 is negative 8. All right, for number 37, you should notice that you have 3 in each of the terms, each of the groups of parentheses here, and there are 7 of those groups. So we've got 3 to the 7th power, which is 2,187. Now 3 of these terms have x's, so that's x to the third, and 4 of them have y's, so y to the fourth. Excellent. All right, I'm going to kind of jump around here. Looking at a problem like 39, remember that if it's not written as a fraction, you can always write it as a fraction by putting it over 1. So I've got 2x over y, and then 2x over 1, and 2x over 1. So in the numerator, I have 2 times 2 times 2 is 8, and x times x times x is x to the third, and in the denominator I have y to the third. Great. All right, hunting around here. If I do number 42, 1/2 to the 8 is 1 over 256. 256. Okay, and we're going to multiply that by negative 64. That's 2 to the third is 8 times negative 8 is negative 64. All right, so negative 64 goes into 256 negative 64 times, so we're left with negative 1/64. Don't be afraid of decimals here. We're going to write them as fractions. So 0.25 is 1/4 to the third. That's 1 to the third is 1 over 4 to the third is 64. Terrific. All right, I'll leave some of the rest of them for you to explore on your own. Try to cancel out as much as you can beforehand. That'll help you to simplify later.